All right. Good. Well, afternoon, evening, wherever we are. So today is all about number conversions. And when you're dealing with number conversions, there's really 4 different numbering systems that are used when dealing with technology. You're either going to be using decimal, for which humans use, or you're going to be using binary, which is what computing devices use. The other 2 we'll talk about later are hexadecimal and octal, but today it won't be, we'll come back to that in another session. So today is strictly decimal and binary numbering system, and to understand why those are so important. So 2 things. Decimal is what our humans use. So people, we use the decimal numbering system. So oftentimes, no matter what separate entities you're talking about, you're going to have to always convert that number system or convert that value into what humans use. And so we use the decimal numbering system. So let's talk about that a little bit. The decimal numbering system has the word dec, which means there are 10 symbols to our numbering system, and those symbols are 0 through 9 that we learned in elementary school. And you know, when you adding +1 and we get to the 9th digit, and that's the largest value, and that place value hit +1, we carry the 1 over. So because of that, we have these place values that we use when we're learning how to count decimal. And so we know that this number is 4,307. But the reason we know that, right, this is all review from elementary school, is that this is in the ones place, the 7, 0 is in the tens place, 3 is in the hundreds place, and then the 4 is in the thousands place. So if I were to carry this out even further, right, because numbers can go on for infinity, right, we can have a whole lot of different numbers. And so we could have thousands place, 10,000s place, 100,000s place, and so forth. And so because numbers go on forever, in order for us to make sense of this, we put them in some type of grouping. So what we do is we add commas. So we add commas so that we can kind of space out our numbering system and we can make sense of what that number is. And so based upon our place values, and so going back to the original number of 4,307, we're actually saying 4,000 plus 300 with 0 tens plus 7, which is actually what we're saying. We learned this in elementary school. So we now, as we're adults, we just do this automatically because this is what we learned in elementary school. So decimal means 10. 0 is a symbol. So 0 through 9 equals our 10 symbols. And this is what humans, this is how we count. This is how we have our numbering system. So this is part of what we have to do. So with that, I am going to add a new board. So with that, we also need to understand, so we got decimal, which is for humans. So the second one I mentioned was binary. So the reason we deal with binary is for our computing devices. So let's talk about our computing devices real quick. So our computing devices, as mentioned in previous videos, have 3 different parts that have to work together. So you have hardware, somewhere along we have an operating system, and then we have some applications or something that allow users to do something. That's an entirely different discussion. But however, our computing devices, whether or not they're televisions or phones, remember, they all are electronic devices, meaning they run off of electricity. So because they run off of electricity only, just like your light switch, can only be on or off. So because computers are electronic devices and they can only understand on and off behavior through hardware, and on is represented as a number 1 and off is represented as a 0. So there's only 2 possible states, either on or off, that can be used by a computing device to represent all of these different unique instances that we're using them for. Records, alphabet, downloading televisions, everything. Computers are dumb. So the only thing they recognize are zeros and ones. But mathematicians and everybody are very, very smart because they figure out ways to make different calculations just to understand zeros and ones. I'm not sure about how all that works. I just know that it works. So because there's only 2 states, that's why we get the word binary, like a bicycle, meaning only 2 symbols. So the 2 symbols are 0 or 1. So those are our 2 symbols. So just like we mentioned in the numbering system for decimal for humans, the same thing applies. Binary numbers can go on for infinity. They can go on forever. But because of that, the way we grouped our decimal numbers, we grouped in 3s with commas. So what happens is, because we need to make sense of all of these values, we group here in what's called a bit. So each one of these digits is called a bit. And so the grouping from binary to decimal, when we're talking about this, is grouping of 8 bits equals 1 byte. So 2, 4, 6, 8. So this would be 1 byte. But because, remember, we're always talking about humans and computing devices, we got our humans over here. This byte could also be a character or a symbol that we understand. So this series of zeros and ones could actually be the letter A. So when you're typing on your keyboard, or you're trying to, humans are trying to create the letter A, that to a computing device is converted, if you would, into a series of zeros and ones. Now, are these series of 0 and 1s the letter A? I don't know. But there are charts out there called the ASCII chart or extended ASCII that can tell you what the zeros and ones mean. And so this series of 0 1s on this side, if we group in 8, 2, 4, 6, 2, 4, 6, 8, 1, 2, 3. If we were to group these in our series of 8, this could very well be the question mark or something. It could be that ampersand sign. But regardless of what humans we recognize, our characters has to be translated to the computing device. So that's really why we have to understand both binary and decimal. So we have to make sure that what humans understand, we can always have a conversation with our computing device. So now, what does that look like?